All right, pre-calc for today, 6.5. We're going to get into graphing tangent and cotangent functions. And then we're going to look at the cosecant and secant functions, but might be a couple of problems like that on the homework, but I'm not going to give you one of those on the test, so at least know how to do them. But let's go ahead and start on this. So tangent functions, you guys. So we've talked a little bit about tangent functions before in class. Let's just remind ourselves of what tangent is. Tangent by definition is y over x, right? Well, y over x is the same thing as slope. So when you think tangent, I actually want you to think slope, right? The slope function is really what this is. And one thing that we've already kind of looked at on the unit circle with this thing is if you think about this, okay, when x values go to 0, we're dividing by 0, which gives us an undefined slope. Okay, so if you're on the unit circle, that happens here and here, right? At 90 and at 270. Every time we get 90 into 270, if that's where we are on the unit circle, the x values go to 0, therefore our slope becomes undefined. So what we end up seeing in the tangent graph is we end up seeing these vertical asymptotes at odd intervals of pi over 2. So I'm drawing that in here in green. So every odd integer of pi over 2, we have an asymptote, and the tangent function is bounded between that. And then like every cycle of the tangent function just continues on to the next section of the graph. Unlike the sine and cosine functions, to get the tangent function, you actually have to plug in the more than 5 points for one, and the points that we choose to plug in are actually all of the points halfway around the unit circle. So we look at 30 degrees, we look at 45 degrees, we look at 60 degrees, and then we, once we know that, we kind of can figure out what the negatives of those are as well. So we need the positive and the negative. So really, we need 4 points, seeing if it goes through 0, right? And then we simply just use symmetry to fill in the rest of it. So let's try this out. So I gave you a chart here, and I can't remember if that's in your notes, but you may want to fill that in the notes. But what I want to do is just talk about how they're getting these things. So at pi over 6 here, we see that they have the point square root of 3 over 3. Okay, well, let's think about that. Pi over 6 happens here, which is 30 degrees, right? So at 30 degrees on our unit circle, if we're at 30 degrees on the unit circle, we know that the y value there is 1/2, and the x value there is square root of 3 over 2. Okay, so all we're doing here to find out what happens at 30 degrees is we're plugging in the y and the x. We take a half, and we divide it by square root of 3 over 2, which is the same thing as 1/2 times 2 over root 3, which is the same thing as 1 over square root of 3, so we have to rationalize that, right? And we get the square root of 3 over 3. Okay, that's how they got that point. And then we want another point for this pi over 4, which is 45 degrees. Well, we know at 45 degrees, you guys, 45 degrees, the slope is 1. Okay, so if you just remember that, if you're at 45 degrees on the unit circle, your slope is 1. The reason for that is at that place, the x and y values are the same. We have square root of 2 over 2, square root of 2 over 2. If we divide those things, we just get 1, right? So that's how they get 1. And then this, pi over 3 is going to be 60 degrees, so it's just going to be the opposite of what we did here, and you end up with root 3. Okay, so this kind of gives you the key points for the tangent function. You can play with that a little bit. And then they show you what the tangent function looks like if you just expand it out, right? So notice that we have it going through 0, then we have it going through pi, we have it going through 2 pi, and then negative 2 pi. It's kind of like where it all centers. Okay, that's the parent function for tangent. Now, we're going to modify these things, and we can shift these things right, left, up, down, vertical stretch, that kind of thing. But this is the parent function. All right, so let's take a look at how we might shift this. Here are the properties of the tangent function, by the way, before we do that. The range is going to be the set of all reals because it goes, it'll go to infinity on the y. But notice that the domain is the set of all real numbers except pi over 2. Odd multiples of a pi over 2 are where we have all of those asymptotes because that's what makes the slope go to 0. The denominator go to 0. The x values go to 0, right? So at 90 and at 270. Okay, so the x-intercepts there, as I just talked to you guys about, are just intervals of pi. We have a y-intercept that happens at 0. Okay, so those are some properties that you might want to jot down. But you really don't need to because, if you know your definitions right, you're going to be fine graphing this thing. Okay, so let's look at objective 1 here, which is graphing a tangent function that's been modified. All right, so for this guy, we have y equals 3/2 tangent of x plus a half. It says use this graph this, and then use the graph to determine the domain and the range. Okay. So let's just start with what we did last time and just see what happens. Okay, so if we started with an xy chart and we use what we talked about already, if we used pi over 3, actually let's start with pi over 6, 30 degrees. Okay, at pi over 6, at 30 degrees, we said that at 30 degrees the slope is square root of 3 over 3. Okay, so now what we need to do in order to modify this is we need to then we need to multiply this by 3 over 2. Okay, and then add it to a half. So when I do this, I get the square root of 3 over 2. And then if I add that to 1/2, I get the square root of 3 plus 1 over 2. Okay, the square root of 3 plus 1 over 2. So what you might want to do when you do that, when you get that, is you might actually want to do it out and get a decimal, just because you're going to be graphing this on an xy coordinate plane. So if I take the square root of 3 and add it to 1, just doing that here really quick, I get 2.73, divide that by 2, I get 1.36 approximately. Okay, so that's pi over 6. Then, so we can keep going. These numbers here are going to, they're going to be, it's okay to use them, they're just not going to be nice numbers, right? That's the key with this. So we have pi over 6, if we do pi over 3, pi over 3 is going to give us, and you can use this chart if you filled this chart in. So pi over 3 we know gives us the square root of 3, right? So if we have pi over 3, we have the square root of 3. Square root of 3 times 3 over 2 is going to give us 3 root 3 over 2. Okay, and then we're going to add 1/2 to this. So we get 3 root 3 plus 1 over 2. Okay, if I take the square root of 3, multiply that by 3, add 1, divide by 2, I get 3.098, or 3.1 approximately. Okay, so this is 3.1. Then at pi over 4, we know at pi over 4 we're at 1. 1 times 3/2 is 3/2. 3/2 plus 1/2 is equal to 4/2, which is equal to 2. Okay, so I guess I should have gone in the other order there. So if I'm graphing this, what I'm seeing is, oh, and by the way, if I go to tangent of, we know that tangent of pi over 2 is going to be undefined, right? So we can't do anything with that. So yeah, I guess we'll stop right there. So at pi over, and at 0, if we put the tangent of 0, if we were at 0, and we plugged it in there, we know that the tangent there is at 0 is 0. We also can multiply that by 3/2, we get 0, but then we add a half, we get a half. So at 0, we're at half. Okay, so at 0, let's just do this at 1, 2, 3, 4. And then we're going to go here, we're going to go pi over 6, pi over 4, pi over 3. Okay, so at 0 we're at a half, right? And then at pi over 4 we're at 2. Okay, then at pi over 6 we're at 1.3 something or other, right in there. And then pi over 3 we're at 3.1. So we kind of have this kind of thing going on. Okay, and then we need to get the full cycle, so now we have to go backwards, right? So if we go back to negative pi over 6, negative pi over 4, negative pi over 3, notice we're going to get the exact same answer, but it's going to be in the negative now. Okay, so we don't really have to do the math for that. We just have to put the negative on each of those. So we got this guy. We got 2 at pi over negative pi over 4. And then we have 3.1 at pi over 3. That's down here. So we kind of have this guy going on. Comes up, goes over. So we got that kind of thing going on. Okay, so that's what it looks like. And then it says to use this to determine the domain and the range. Okay, so we're still, since we haven't modified the inside of this function, I mean, we did shift it upward with that 1/2, but since this was not in parentheses, we're not modifying the inside. So we're still bound by pi over 2. So at pi over 2, we have this asymptote. And then at negative pi over 2, we have an asymptote. Okay, so the domain is all reals except for odd multiples of pi over 2. And the range is going to be all reals. Okay, and so here's their solution for that. They first graphed the tangent function, then they multiplied it by 3/2, then they shifted the whole thing up by a half. So they used transformations a little bit different than what we did, but still, nonetheless, getting similar answers. And they only used 3 points here. I encourage you to use more, just because if you only use 3 points, it might look like a line.